Okay, here we go. Alright, we're going to do 4.5 notes. We're going to start off with the two parent functions. If you want to graph y equals sine x. Okay, this is a review from Algebra 2 Trig. Thank you. Alright, so we know that the domain of sine is all real numbers, and the range is from -1 to 1. We're going to use the unit circle to help us plot the 5 main points. And what else did I know? Domain, range. Oh yeah, the period length. Okay, and the period length is 2 pi. So what I like to do when I'm graphing a trig function is I make 4 tick marks and call it the period length. And so I'm going to get my points from the little unit circle. Remember, every ordered pair goes cosine, comma, sine. So these are the y coordinates. So the sine of 0 is 0. I come up here and the sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. And then you just follow the pattern, continuing it to the left. Now when you do your homework, we're going to spend 2 days on this lesson, so it'll be due on Wednesday. Wednesday we're going to start 4.6 and get about halfway, and then we'll pick it up after break. But when you are checking your graphs in the back of your textbook, it does not matter if you have one period length right and one left, or there's 2 to the right. I think the textbook might go 2 to the right instead. I personally prefer one left, one right. But it, really doesn't matter. Okay, do you guys remember this from last year? Okay, so now, if you want to graph y equals cosine x, we still have the domain is all real numbers. The range is from -1 to 1. The period length is 2 pi. And remember, period length is how long does it take until the graph will repeat the pattern. So then cosine of 0 is at 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine 3 pi over 2 is 0. Cosine 2 pi is 1. And then you just continue the pattern. So now, when we look at the cosine graph, I want to pause here a moment and make a connection to something we've covered previously. If I were to fold my graph onto the y-axis, what kind of symmetry does it have? Y-axis symmetry. Yeah, that was a real stretch, huh? There's your y-axis symmetry. Now, if a graph has y-axis symmetry, what else do we know about it? It's even. So, this means f of x equals cosine x is even, which means f of negative x equals f of x. Or in other words, the cosine of negative x is just the same thing as cosine x. So we're going to make a connection to symmetry and even and odds with our trig functions as we've done with others. Now think about this last statement. The cosine of negative x equals cosine x. Well, the cosine of pi over 2 is 0. The cosine of negative pi over 2 is 0. The cosine of pi is negative 1. The cosine of negative pi is 1. The cosine of 3 pi over 2 is 0. The cosine of negative 3 pi over 2 is 0. Do you see how that really is true? So then, all right, let's look back now at the sine x. It definitely doesn't have y-axis symmetry. It doesn't have x-axis symmetry, but it does have origin symmetry. Can you guys take your paper and turn it upside down? Do you see the graph of sine x really is the same if it's up or down? Well, what that means, if you have origin symmetry, f of x equals sine x is an odd function. So f of negative x equals negative f of x. This is going to help us in the next chapter. So if I know the sine of negative x, that's actually negative sine x. All right, so let's take a moment and just, let this sink in. So sine and cosine, for their parent functions, their domain, range, and period are the same. What's the only difference on the graph? I mean, they're very, very similar.
Cosine is shifted to the right one.
Yeah, if you look at it, the cosine graph, it depends on, which way you want to look at it, is you could take this one and shift it to the right, pi over 2 to produce sine, or you could take this one and say you're going to move it back pi over 2, depending on which one you start with. All right, so is this coming back to you, like you remember this from last year? All right, good. Alright, so example 1. If I want to graph y equals 2 sine x on the interval from negative 2 pi to 2 pi. Does anybody remember from last year or even what we've reviewed this school year, what happens if you change the number out front? It makes a vertical shift, doesn't it? So what we're going to do here is the period length is still 2 pi. But instead of going up to 1 or down 1, we're going to you need to somehow keep it straight that the sine of 0 is 0, but then it's going to go up to your amplitude. So I always plot my 5 main points and then just follow the pattern. Please make sure that at that amplitude, you don't have points, and what I mean by that is like a pointy V. Make sure it's a smooth curve. I've seen students over the years who do this. I'm like, that's not the graph. Okay, so don't do that. All right, so I'm going to give you a definition. The amplitude of y equals a sine x, or y equals a cosine x, is the absolute value of a. amplitude represents half the distance between the maximum and minimum values. So if you'll take out your graphing calculators, I'd like us to do just a teeny tiny little exploration here to explore and to make sure we remember how to get this in the calculator. So go to your y screen, and in y sub 1 we're going to put the parent function, y equals sine x. Y sub 2, let's do 3 sine x. And in y sub 3, let's do 4 sine x. Now if it's asking for negative 2 pi to 2 pi, we want this to be in radians. Okay, we definitely want this to be in radians. So check your mode. And then let's do zoom trig. Okay, let's do zoom trig. And mine's really neat because on the color calculator, now you can see here comes the parent function was in blue. Here's 3 times sine x. So notice it's going up to a maximum of 3 and a minimum of negative 3. And then here comes my 4 sine x. That's really neat to see that. Okay, again, check your mode, and then you can do zoom trig. Notice that the x-intercepts are the same. Plane with amplitude does not change left-right. It just changes the vertical. Okay? Alright, so that's amplitude. Alright, now what happens if you put a negative out front? Okay, the period is still 2 pi. Now what I want you to know, amplitude is not a negative 3. Amplitude is a distance, and distance cannot be negative. So my amplitude is the absolute value of negative 3, so it's just 3. So here we go. I'm going to go out to, I always make 4 tick marks, and the 4th tick mark I call the period length. I'm going to go up to 3 and down to negative 3. So now, when there is a negative, instead of with cosine that would normally start up at the amplitude, remember now this is cosine, so cosine is going to start down at the opposite of the amplitude, or it'll start at where A is, if A is negative 3. So then it'll go 0, then up, so it's just a reflection over the x-axis. Again, make sure at your kind of turning locations that it's rounded. Okay, you want it to be rounded there. Recall from section 1.5, the graph of y equals negative f of x is a reflection over the x-axis. Alright, so we've talked about amplitude. Amplitude is the absolute value of A, and that gives us a vertical stretch. Now we have the period length. the period of y equals a sine of b times x, or y equals a cosine bx, is 2 pi divided by the b value. Okay, so period length, we can adjust that. It's 2 pi divided by b, where b is the number in front of x. A note before we compute the period length: if b is a number between 0 and 1, the period of y equals a sine bx, or y equals a cosine bx, I'm not going to write out both, is greater than 2 pi. And represents a horizontal stretch. So for example, if you had 2 pi divided by 1/2, that's 4 pi. That's going to stretch your graph out further. If b is greater than 1, the period of y equals a sine bx is less than 2 pi, and represents a horizontal shrink. And so we're going to look at an example. Alright, so if I have y equals 2 cosine 3x, then the period length is 2 pi divided by the b, so it's just 2 pi over 3. And do you see that that is a horizontal shrink? Because that's not definitely as big as 2 pi. It's a lot smaller. Alright, and what about in this one? Y equals negative 3 sine x over 4. Well, the period length is 2 pi divided by b. Well, but what's b? 1/4. It's not 4. Okay, the number in front of x would be understood to be a 1/4. So 2 pi divided by 1/4, you would, when you divide by a fraction, you multiply by the reciprocal, so it's 8 pi. So this is definitely a horizontal stretch. It's 4 times as wide